is take a peek at what's called conditional probability, which means if this happens, and typically you see the word given, we started to talk a little bit about before we got into this even, we can start to work it. Now, like I said, there is a mathematical formula way for me to figure these out, but to me, it actually makes this more complicated. And I'm going to use the example as my example of making this much less complicated. Naomi's playing a game with the spinner shown. What's the probability that the spinner lands on 7 given Naomi has spun a number greater than 5? Now, I could do this whole deal right here. Probability of A is 3 out of 8. She spun a number greater than 5. Okay? This number greater than 5, 6, 7, or 8. Well, how many outcomes are both? Greater than 5 and that she lands on 7? Well, 1 out of 8, because there's 1 out of 8 chance she can get a 7. So I go ahead, I work that through, I divide, I get the answer. Let's make this easier. When I see the word given, anything that's after that is telling me what the denominator of the fraction is. It's telling me the total options that I have that could happen. Given, Naomi has spun a number greater than 5. Well, let's see, a number greater than 5. There's 3 of them. Okay, that's my denominator. What's before the given? What's the probability that the spinner lands on 7? How many places can it land on 7? 1. I get the same 1/3 that they got by going through all the other things. So basically, they're giving you the numerator and the denominator. You're just looking at the number of options for each. And that's all it's going to be anytime you're doing these. So for instance, cards are drawn from a standard deck of 52 cards. Find the probability. Find the word given. Given. An ace is drawn. Well, there's 4 aces in the deck. So the denominator of my fraction is going to be 4. Then I go back to the beginning. The card is a heart. Now, you're like, wait a minute, what's that mean? Given an ace is drawn, the ace is a heart. So what I'm basically saying is, it's the ace of hearts over the number of aces in the deck. If an ace is drawn, I have 4 options. Ace of hearts, ace of diamonds, ace of spades, ace of clubs. The ace of hearts is one of those 4. I'm done. It just gets into a lot less opportunity for you to be able to flip a fraction around or do probability of B given A, or you do A given B instead, or something like that, just by breaking it down. So given a club is drawn, again, what's my odds of getting the 6 of clubs? Okay, so it's chances of getting the 6 of clubs out of the total number of clubs that there are. Well, there's 13 cards that are clubs, because there's 13 of each suit, but only one of those is the 6 of clubs. So again, it's all about where is given, because whatever's after it, I can make that work. Given a black card is drawn, the card is a spade. You're like, okay, let's see. So I need a black spade, which would be any spade, over the total number of black cards. Well, the black cards are clubs and spades, 13 and 13. There's 26 of those. Spades is one whole suit. There's 13 of those. So I have a 50-50 shot of getting a spade if I know it's a black card. But again, it's about keywords, and this time the keyword is given. because then I just take that and I work it with whatever's after. So again, as long as I find given the roll is even, 2, 4, or 6, which means there's 3 options, a 4 is rolled. One of those 3 numbers is the number 4. I'm done. Given the roll is less than 6, 1 through 5, 5 options. How many of them are 2? 1. But again, I've got to keep the right order of things here. Given the roll is 3 or 4, well, there's only 2 options, 3 or 4. An even number is rolled. 4 is the only even number. It's 1 out of 2. Don't get them flipped. Put the even numbers in the bottom and 3 and 4 on top. It's whatever's after given is my denominator. Whatever's before it, how many opportunities there are for those 2 things together to occur would be my answer. Like I said, we like to try and keep this as simple as humanly possible. So when I get to the back with something we call a contingency table, this happens when this happens, or, what outcomes are there? Now, the one nice thing they did for you already that you would typically have to do on your own with something like this is figure out how many total students there are. Now, sometimes that can come into play because, again, books tend to make this more complicated than it needs to be. I'm just going to use the information in the guide to serve as my guide because I still see that the word is given in here everywhere. Given this person is in the bride's family. Now, the bride's family includes both people that can and cannot attend. So I have to add those up. So the people in the bride's family total 136. Well, what part am I looking for? The people that can attend the wedding, that are in the bride's family. It's got to conclude both. So there's 104 people in the bride's family out of the total that can attend, and I always want to reduce as far as I can. But again, notice I had to find a total that time that was different than just what's given me in the chart. Totals are going to become a part of this I have to do. Okay. The baseball over here. Find given. Student is a senior given. Okay. Play baseball given a senior. Seniors. Got to add up my seniors here. So there's 340 seniors. How many of them play baseball? 34. And I get that. But I mean, the total can be coming vertically, horizontally. I have to read and be careful and make sure I get my information correct. Okay, so one last big one here. Shopper uses a credit card given the shopper is shopping at Jacob's Gas. So here's Jacob's Gas. So I need to find the total number of people for that, which is 1140. How many people who shop at Jacob's Gas, I'll spit it out, use a credit card? 456 of them. Reduces all the way down to 2/5. But again, just keep telling yourself, after the given, Pet Town, got 147 people that shop at Pet Town. uses a debit card at Pet Town. Got to cover both. I get my solution. Finally, a shopper is shopping at TJ's given shopper is paying cash. Here's all my cash flow, people. 595 of them. Shopping at TJ's given the cash part. 102. So again, don't make the given become something complicated by forcing yourself into using a formula when you don't need to use it. Whatever's after the given becomes your denominator, that total. Whatever's before, using both things, credit card at Jake's, debit card at Pet Town, cash at TJ's. Come up with your numerator that way. So like we mentioned before, even though I know it's Tuesday, we're not going to go overly crazy on you here. This will be numero uno for homework check 16. What do we get there? So if you still need to be working on the worksheets, do that. If you're getting a head start, you want to knock these out, cool. But that homework check will be then. And we may, by mid-end next week, be looking at our quiz in this area. We will see.